All right, our next shape is marry the rhombus. So remember, based on our definition, a rhombus is a four-sided shape, quadrilateral with congruent sides. That doesn't necessarily mean all the angles are congruent, as you can see here, but it does have all the properties of a parallelogram. So opposite sides are parallel to each other. Opposite angles are congruent to each other. So like angle A and angle Y are congruent, angle M and angle R are congruent. Our diagonals bisect each other. That is still a property. And then the additional property to that, so I'll put my little congruent marks here, is that the diagonals are actually perpendicular. So there's a right angle here. And remember, if there's a right angle, that means all angles in the center are 90 degrees. So all center angles equal 90 degrees. Okay, so looking in our diagram here, now I'm going to pick a different number than what's on your practice test so that you can kind of practice it, see it with a different number and then practice it independently. Okay, so first thing we want to do is look at this diagram, and we've got 90 degrees all in the center of the figure. Okay, and then I'm going to give you an angle measure. Let's just say this is 62 degrees. Okay, now what you should be able to do is identify all of the other angles that are also 62 degrees. Now, in addition to our opposite angles like A and Y being congruent, well, they're also bisected. So these parts here, all four of these little angle parts are actually equal to each other. Same with here, all four of these angle parts are equal to each other. Okay, so that means we have a 62 here, and these two are going to be congruent up here. So this is 62 and this is 62. So essentially, if you're looking here, we've got four congruent right triangles. Okay, now we know the angles at the middle are all going to be 90s, 90. And we also know the triangle sum theorem states that a triangle has 180 degrees. Okay, so I would say to find, this angle here, which is going to be, these four are congruent, we could take 180 degrees, which is the full triangle, subtract the 90, which is going to give us 90, and subtract the 62, which is going to give us 28. So that's going to be the measure here for angle 3 and over here for these two angles as well. Looking in our diagram at another angle problem. So we have our right angle here at the center of our figure. That's going to be a 90-degree angle. And then we have our two angles here as well. So we don't know if they're equal. Remember, in this diagram here, they were not equal, 28 and 62. So we're not setting them equal to each other. So not equal necessarily, right? But what we do know is that they, together with this 90-degree angle, add up to the total degrees in a triangle, which is 180. So I'm going to take 180 in the triangle. I'm going to subtract that 90 I already have there, and I get 90 degrees left. That means these two angles here add up to 90 degrees. So in a right triangle, your two acute angles are always complementary. They add up to 90. So what that means is 6x plus 4 plus the 5x minus 13 should equal 90. Okay. Once you've done that, you then also know that this angle 1 here is congruent to this angle. So you can substitute x in here. And then the last rhombus question has to do with the sides of a figure. So first thing we might want to identify, so we have QS, that's this entire diagonal segment, that is 14. I'm going to go ahead and split that into two equal parts of 7 and 7. We also know that PR, that is 18, that is this entire diagonal segment, that is 18, so I'm going to split that in half, and I'm going to get 9s for each of these pieces here. We know that these are all right triangles, and I put my right angle symbol in the middle. What we're looking for is PS, which is this piece right here. I'm going to just use a variable C for that. So this is the right triangle we're referring to. Let me just draw that off to the side. So this is C, the length that we're solving for, the PS side, and then we've got a side length of 9 and we've got a side length of 7. So you should be able to use your Pythagorean theorem for this. Anytime you know two sides of a right triangle, you can find the third missing side.